This is Unit 6, Lesson 2, Who Will Win at Skee Ball? Today we are going to dive deeper into discrete random variables, and we are going to learn how to analyze them. Okay, so for this one, we are playing the skee ball game. If you guys remember Dave & Buster's or Chuck E. Cheese, this old skee ball game, and it's going through the probability of getting the ball into these different slots on the skee ball. So this is giving you, we have a game, Mr. Wilcox versus Mrs. Gallus. And the scores to be able to, the points are 10, 20, 30, 40, and 50. And the probability, meaning basically Mr. Wilcox went ahead and tried the game, and then Miss Gallus tried the game. And this is the probabilities they got for each one of their scores. So we're going to go ahead and do our lesson based on this. Now, the first thing I did is I told my students to get a calculator and put the data into the spreadsheet. In order to do that, you're going to go to New Document, and then you're going to go to List and Spreadsheet, which is number 4. And then in your A column, or it doesn't matter, you're going to put X, and then the B column you're going to put, I'll just put A column, and then B column you're going to put the probability. Now, it's very important, and then you're going to do the same thing for this one. You can do another list and spreadsheet if you'd like to, or you can continue putting this in the C column and the D column, because you're going to end up needing all of these in there. Let's go ahead and discuss, is this discrete or continuous? And as we learned about discrete yesterday, this is the values it's talking about, that there are definitely gaps in between here. On this game, I can't score anything between a 10 and a 20. I have to score exactly 10 or exactly 20. So this is discrete. Discrete, remember, is when there's gaps. And then what we're going to do is we're going to make a probability table. So you can see the way I did that is at 10, I went up to 40% because that's 40%. At this 10, I went up to 2%, which is right here, and so forth and so on. And then I described the shape. This is definitely skewed to the right because I've got most of my data here at the left side, and these little values here are pulling the picture towards the right and making it slant downward to the right. This is fairly symmetric. It's not perfect, but if I threw a blanket over it and I kind of had a distance away from it, you would see it's about symmetric. Of course, it's not perfect, but that's why I say fairly symmetric. Please notice, in order for a full graph, as I have the title, and I've got things labeled, and I've got the tick marks here. All right? Okay, so the first thing I'm going to ask you to do is find out what's the probability of X greater than 40. If the game was to get 40 or more, greater than or equal to. If the game was to get 40 or more points, who would win? So what we did is we found Mr. Wilcox was here, and then Miss Gallus was here, but we could also look at it from here, and we added it, and we saw, oh, Mr. Wilcox would definitely win if the game was to get 40 or more points, if that's the only thing that counted. So then I asked you to find the average of the X values. So to find the average of the X values, this is what I got. 10 plus 20 plus 30 plus 40 plus 50, and I got that for both A and for B. But the reason that's incorrect is you can see the graph, 10, 20, 30, 40, 50, they're not weighted at the same amount. You can see this one is weighted more than these, and 10 happens way more often than 20, and so 10 and 20 should not be equal. Because if 10 and 20 were equal, I'd do 10 plus 20 divided by 2 is going to be 30 divided by 2 is 15. And I'd say, oh, well, I got an average of 15 points. But I didn't, because I got 10 definitely more than I got 20. So I have to do what's called a weight. And the weight is basically this, is I am going to take each of these values, and I'm going to ask you, I'm going to tell you, okay, guys, how much percent of the time do you expect to get a 10? Well, 40%. So how many points do you expect to get from the 10 slot? Well, 40% times 10 is, so 10 times 40%, because 40% of the time I plan on getting 10 points, and so that's going to be about 4 points I'm going to get from the 10 slot, because 40% of the time I'm going to get the 10 slot, and so that's about 4 points on average. 20% of the time I plan on getting a 20, and so that's 20% times 20, and that's also 4. 30% times 20 or excuse me, 30 times 20% is 6 points. So this is the average number of points I'm going to get from each slot. And then 40 times 14%, and that's 5.6 points. And then 50 times 0.06, and that's 3 points. So if I add all of these up, this here is actually going to be my average score, and that's what I'm doing down here. Now let's look and see. As you can see, I got 22.6 points for my X. Now, this here is this goofy little formula, and I'll tell you what these means. XI just means this is X1, X2, X3, X4, and X5. We can call those XI, where I is each slot of points, right? And then P, this is my P, probability. This is P1, P2, P3, and so forth and so on, P4 and P5. So you can see, and this little symbol means add them all up. So that little symbol means add them all up. It's my sigma notation in math, and that basically means something plus something plus something plus something plus something. So what it's telling me is I'm going to take all my X's and multiply them by all their probabilities and add them all together. So I'm going to do the same thing for my Y, and my Y, all I would do is add this. I would say 10 times 2%, 20 times 28%, 30 times 55%, 40 times 0.1, and 50 times 0.05. Add these guys together, and I'd get the answer. Now, in the meantime, I did tell you to put it in your spreadsheet because I'm going to show you another way to do it on your calculator. Because we did this by hand, and the standard deviation is much more complicated, which I'll show you here in a second, but I'm going to show you how to do it on your calculator. So let's bring this up here, and I'm going to just type this one in and work on this, and you should have already put this in your calculator. So hopefully you did, and if you didn't, let's go ahead and put it in with me. All right, let's put here. Okay. Oops, here we go. So you're going to open up a spreadsheet. And you have to, I'm going to go ahead and put this as my X values, which I'll just put as skee ball. All right, go down here, and I'm going to put, of course, I can get from 10 to 50. So 10, 20, 30, 40, and 50. And then this next one is my probability. Oops. So I have to label it. I'm just putting probability sample. All right, so here is going to be 0.4, 0.2, 0.2, 0.14, and 0.06. All right, and I told you guys to go ahead and put C and D also in there. And if you did, you want to jump over to column E because you don't want it to overwrite your data. But I'm just doing one at a time. So I'm going to go to menu 411 OK. So menu 4 is statistic, 1 is stat calc, 1 is one variable statistic, and then OK. So I'm going to do my X list, and my X list I called was Skee. And then I'm going to go to the frequency list, and I called that as prob sample for mine. And then I'm going to hit OK. And here we go. My mean is 22.6, and my standard deviation is 12.7, which is right here what I got. I got the mean here is 22.6, and the standard deviation. So the mean was my X bar, and the standard deviation you're going to see is this symbol here. Now, let me show you how to do this by hand. All right, so how to do this by hand is you saw the formula that I just showed you for the mean was this symbol here, XI, where you did 10 times 0.04 plus the next one, plus the next one, plus the next one, plus the next one, times the last one. That's why I'm going to put ... times 50 times 0.06, and you got 22.6. The standard deviation, this is a really other goofy formula, And it's another summation, so you're going to add things up again. But now you're going to get your each x minus the mean squared times the probability. So let's go ahead, and this is going to be long, but I'm going to write it all out just so you have it. Actually, I'm going to start it here because it is super long. We're just going to do it this one time, and then I'm going to show you how to do a shortcut just because I want you to understand where all the numbers are coming from. Okay, so I'm just going to kind of set us up because look, this is what you're going to do. You're going to literally just keep doing this. And so forth and so on. Okay, so this one, the very first, so this here, let's look here. This first is my x. You're going to put all the x's here. All right, so x here. So x is all my x's. Remember, these are my x's from here. 10, 20, 30, 40, 50. So 10, 20, 30, and so forth and so on. Okay, the next one, let's go ahead with this, the mean. The mean is always the same right here. The mean we found is 22.6. So 22.6, 22.6, 22.6. Now I haven't finished them out. I've just done the first 3 terms so far. Okay, and the next one is going to be my probability. And the probability is going to be this, all these here, these probabilities right here, right? Those are the probabilities. And that's what goes in here. Okay, so the probability for the first one was 0.04. The next one I think was 0.02. Just forgot what, 0.2, sorry, and 0.2. So not 0.04, but, so let's get that, C. So 0.4, 0.2, 0.2, and so forth and so on. So you would keep going. So you'd, the 30, and then 40, and then 50. But I'm just going to show you that this is here, and then you could throw that in your calculator, or you could just look here and see, oh, it's right there, 12.78. And that's what we got from here. So this is the way you would do it on your calculator. I need to make sure you know how to do that so that you can get this correct on the test. All right, so let's look here at your notes. The main thing is I need you to see on your notes is when you describe your shape, it's either going to be skewed to the right, which is the data going to the right, skewed to the left, data going to the left, or symmetric, which is about the same on both sides. And this, of course, is a histogram. The mean is equal to the summation of all my x's times all my probabilities. And what it means is after many, many, many times I've tried this, the average, for ours it was skee ball points, so that's what context means, whatever you're talking about is, and then whatever your mean is. Learning target number 3, you can use an applet if you'd like. There's many, many applets on here, but I put calculator to get the standard deviation, and I showed you here's the formula, which is what we did. And it's, again, it means many trials. The skee ball typically varies from the mean, which we got at 22.6 by about 12.8 points. So that's our particular one. Now I did also include for you how to make a histogram. And so here's the instructions of how to make a histogram. And then I also include for you how to make, in the little green area, how to make the menu 411, which is what we just did. I just demonstrated for you. I'm going to demonstrate for you how to do this histogram, just so you see it on mine. Mine's a little bit different on my iPad, which is what I'm teaching from. But this is the, if you follow these steps, you'll get there. So I'll tell you. So the first step is to make your data table. Then the next step is you're going to go menu, new document. And new document, you're going to go to number 5, data statistics. You're going to put yours here, and I called mine skee ball. Then do not do anything. Don't tap the Y, because if you tap the Y, it's going to do an X, Y, and it's going to make you like a line or an ordered pair. You don't want that. You want a histogram. So you're going to hit menu, plot properties, and number 9 on your calculator is add Y summary list. And on that one, that's what you're going to choose. What I called mine, again, was prob sample. And there's your histogram. If you remember, histograms touch. They do not have gaps. So you can just go ahead and on your, I'll show you kind of, you can just draw it on yours. So if I drew mine, I would just say, okay, I'm just going to go ahead and make this, going to finish here, and then. So you see what I'm saying? Like, that's what your histogram should look like. And so forth and so on. So you can do that. And, when you draw it, just make sure you understand the histograms touch and you don't have gaps in between them. Or if it really bothers you, you can go to Menu, Plot Properties, Histogram Properties, Bin Settings. The bin is how wide the histograms bars are, equal. And I'm going to say, look, I know there got to be 10. They have to be 10 because they're 10 wide. So I just hit 10 and it does it for me. If I want to see the data better, I can Menu, Window Zoom, Zoom Data, and there you go. Okay. Now for the check for understanding on the snow day, and make a histogram just like I just did. I'm not going to demonstrate it again because I just showed you. You're going to do the same thing, put the data in and do what I just showed you. And then calculate, interpret mean. How do you do mean? See how I have all the yellows highlighted? It highlighted in yellow, 0 times 0.33. And here we go like this. And 1 times 0.19, and so forth and so on and so forth, so on, and add them all up, and you get 2.17. And then calculate and interpret the standard deviation and the mean. The mean is going to be 2.17, and the standard deviation is 2.4. So that is the end of this lesson. So I hope it helped you. And I will see you next time.